We had a swarm of the earthquakes at the Reykjanes ridge inside the Atlantic Ocean, where the mountain range, which we call as the Mid-Atlantic Mountain Range or Mid-Atlantic Ridge, created a rise in the ground. This is caused by the rising of the material from the mantle of the earth, which, like any other movement, create earthquakes. The earthquakes are picked up by our seismometers, and this is where we have this swarm of the earthquake happening. We have two clusters of it, of course, and we have also Reykjavik volcanic system active. The two clusters, one was at the 7 p.m. yesterday, last night, and the next one was just a few hours after that, after the midnight. So these things show that the movements of the lithosphere, earth crust, at that area is continuing. This also is associated with another movement that we have, earthquakes, at a depth of the 5 to 4 kilometers with very tiny earthquakes at the Reykjavik on the land. Reykjavik area is a volcanic system after the in the Reykjanes Peninsula of Iceland. Here we see in the Svartsengi volcanic system, we are expecting eruption there soon. Rising of the material, they're spreading around its surrounding area to the other volcanic systems. As you can see, the GPS data shows that. We see the difference in the height of the ground measured against the satellites in orbit. We see that movement of the magma. If we want to visualize it, I have also another diagram which shows that. This is just my addition on this, making it more easy to see. The spread of the material from the mantle of the earth to the deep magma source creates also this kind of pattern. When we look at it, is something like this. You can see that magma is rising, two different volcanic systems, but they're all connected to the mantle of the earth, of course, and they're supplied by that. And in this cartoon, I show this also. Svartsengi and Reykjavik both have shallow depth magma reservoirs. Reykjavik is actually in the process of building this shallow magma reservoir with a swarm of the earthquakes, clusters, I should say, of earthquakes there. I have many videos about these processes. I'll put some of them here so you can watch them and enjoy. We had several big earthquakes in the Atlantic Ocean, in what is called the Reykjanes Ridge. It is underwater earthquakes on the ridge of the land, which is created when the Mid-Atlantic Ridge split the Eurasia from the North America. The extension of this land, when it comes at the surface, is called Reykjanes Peninsula. And you can see to the left we have the North America, and the right is the Eurasia. Here you can see in the form of topography. Iceland has been created at the middle. You see Scandinavia in the top right, and the UK in the middle of near the center right. This is where this split is happening, and this split and the cracks are creating these earthquakes. The land is extended, the earth lithosphere is extended there, is spreading, and this spreading creates this new land by the magma coming up because the pressure is removed. In other parts of the planet Earth, we have collision, those red parts. Here we have the extension. If you look into the Earth mantle, you can see the effect of this. Land being subducted and the mantle plume coming up, creating new land also. The earth crust at this area, Reykjanes Ridge, is not more than 5 kilometers thick. The depth of the earthquake was 10 kilometers, so that we can say safely it was in the mantle, or the top of the part of the mantle, where this split is happening. On the land, we will have earthquakes, like what we saw in the Reykjanes in 2021, then followed by eruption. We can conclude that these earthquakes, if they happen in the Reykjanes Ridge, we can also have similar underwater eruptions there. And the situation is really interesting. We are lucky we see that on the land in the Iceland. At the moment it's happening at the bottom of the ocean. When we plot the earthquakes and the volcanoes on a map of the world, we find that they are concentrated at certain areas. This is the way we discovered the plate boundaries, and we discovered that the earth actually is cracked. The cracks through which eruptions of volcanoes may happen. Before that, also we may have earthquakes. And first we discovered that the certain coastal areas of the world, for example, Africa and South America, match together as if they have been joined together in the past. Alfred Wegener discovered this first. Now we know that the Earth continents are actually not in the original place that they have been. They have moved many times over since the creation of the Earth in 4.5 billion years ago. And this process is continuing. And where we can see the process actually in real time is in Iceland, where we have the creation of the Atlantic Ocean leading to the formation of this island. Inside the Earth is hot, practically due to the impact heat that was introduced to this planet during the formation of it. And this heat creates convection, and the convection leads, when it reaches the surface, the solidified crust at the top of the mantle creates cracks in the ground, as you can see here. And these cracks are where the separation or extension of the crust happens, and the magma forms, fills the gap created simultaneously. So there is no practically a gap. And the eruption in the Iceland is of this type. In the Red Sea, we have another example, Afar Triangle or Africa, or Rhine Valley in the Germany, we have that. We have these eruptions in the water most of the times, like what we have in the Reykjanes Ridge, which is a plateau inside the Atlantic Ocean. Part of it reaches the land. Practically, they are the same as the volcanic systems we have on the land. One of them is the LD volcanic system, similar to Svartsengi or Reykjanes volcanic system or Hengel. And this can potentially erupt inside the ocean. It has done in the 19th century and 20th century. And it is possible that we have another eruption recently. LD itself is something like a Thorbjorn Hill near the Svartsengi geothermal power plant, where the Blue Lagoon is a volcanic rock. It's the top of the ridge of the volcanoes that have been, most of it has been eroded. When we look at the tremors chart, we can see that the earthquakes start from the Reykjanes Ridge and extends into the Reykjavik Peninsula toward the east. Always starts from the LD, like a wave traveling through the earth, reaching the other side. And the volcanic systems on the Reykjavik Peninsula are created like that, very similar to what we have in LD. LD, if it erupts, will be in the ocean, of course, at the depth 60, 70, 80, 100 meters. And when it reaches the surface, it may react with the water. Lava has chloride in it, and chloride can disintegrate, create chlorine. Chlorine gas is one of the byproducts of these eruptions. Also lots of water and CO2, not compared to what we have actually created by, releasing them from the, oil and gas over the last 200 years, of course. This is an ongoing process. When it reaches the water, like what we saw in the Cumbre Vieja volcano, it can cause this kind of reactions. I have a video about what happened in Cumbre Vieja. Please watch that. Apocalyptic views of lava flow from the Cumbre Vieja volcano. Now 2 months has passed. Volcano has not stopped. It's coming directly from the core mantle boundary, like a welding torch. Made a hole in the Atlantic Ocean and created the La Palma originally. Now is adding to the land mass of the island. But the lava is flowing down the hills, going toward the ocean. This is the flow that nothing can stop it. I will show you a map that shows how it moves toward the sea, where it has covered actually. When it reaches the sea, it just looks like Jurassic Park. Things are falling down, rolling down. The seawater waves are coming toward the headland created by these lava flows. Any moment you may see a dinosaur coming out of there, or King Kong. And that is how it looks. This is a 3D model we have created, and it shows the lava flow, where it ended up on the sea. The older ones, you can see that they are created layered lava as cliffs that we see. It's apocalyptic view. It's a very strange phenomenon. During the last 70 million years, when the Tethys Ocean was closing and the Asia and Europe were joining together, forming a supermass, Atlantic Ocean was forming. Iceland was separating from the Greenland, and that created, through the mid-Atlantic ridge opening up, the island we call Iceland. Volcanism was rife in this area, and is rife now even. You can see it erupts in the Grindavik, made the town uninhabitable for the people. And through these eruptions, we know that when a plate moves, it has to accommodate the motion. We see the evidence in the position of the earthquakes. Earthquakes move in this diagram I've made from the west toward the east. As one opening of the gap creates eruption, a transform faults in black arrows has to transfer it to the next fault lines. These are different systems. We call them different systems. Vegetable system, Kristofik system. Kristofik system is the one that we are talking about now. So like a domino effect, when one moves, lava erupts through that fault line. The next one has to move also accommodate the motion. And as you can see, it goes like a domino effect across the Iceland toward the east, separating these plates, Eurasian plate and North American plate, from each other. Kristofik volcanic system is actually the volcanic system which is taking all these movements, accommodating them through it, and has to transfer it to somewhere else. Transferment in that sense means opening up. And by opening up, it creates volcanism. It has done it in the past. We have seen evidence for it all through this, slanted line. You can see Kristofik is one of those systems. It reached once the vicinity of the Reykjavik, the capital of the Iceland. And it can do it again. We see the vegetable system, and now movement through that toward the Grindavik, we can see it. And again, this movement is transferred again to the Kristofik. Through this mechanism, I like this chart, I'll show you again. Kristofik was active in the 12th century for 37 years, created the most huge fire, because fire will mean eruption in that sense. Because the volcanic system is under very, highly saturated bedrock, it created huge fires, phreatic eruptions. These phreatic eruptions are huge compared to this little fissure compared to the person standing beside it is amazing. Something like what we see in the Reunion Island in the in the Indian Ocean, or what we saw in the Cumbre Vieja, hundreds of meters of the ash and lava erupt into the air. When it happens, it will be big. I may reach the Reykjavik. I have a video I will show you that. Although in this video I've called it part of the vegetable system. When the mid-Atlantic ridge reaches Iceland, it has created several peninsulas. One of them is the Reykjanes Peninsula, created by the volcanic system that you see the names of them here. They are tectonically similar to the Bodden edge structure, shear structures that we see in the rocks. Is the extension creating fault lines, and the fault lines, through them the lava may erupt. We see them in micro scale in the rocks. You can make it with a plasticine if you have the time, a model of that. And the extension can create fault lines that the lava can rise through them. In the case of the systems, these systems are directly connected to the mantle. Reykjavik volcano was such a volcanic system. We found that with this discovery that this Reykjavik was connected actually to the earth mantle through a dike. The dike is fed by the mantle. And as the eruption happens in this area in 2021 in Reykjavik, 22 in the Meridil, and Little Horto in the 2023, it may happen and extend to the years beyond. From 2025, will be a slight angle toward the east, as you see in the other systems parallel to it toward the east. And by 2030, it's quite possible that this system may reach the Reykjanes or the suburbs of it. This is the day that you will see the volcanoes actually erupting inside the town or near the outskirts of the town. This is a scary scenario. And this is one of the several scenarios that may happen. This volcanic system may not reach as far as the Reykjavik, But in this model that I presented, if it reaches there, that will be just outskirts of the town.